Previously, we have learned about magnetic field. Now we will learn how to determine the direction of the magnetic force experienced by a charge moving in the magnetic field using right-hand palm rule. Let's have a look at this positive charge as our example. First, take your right-hand palm. These 4 fingers will indicate the direction of the velocity. Then, our thumb will represent the magnetic force. Meanwhile, imagine there's an arrow pointing out of your palm. In this case, our palm will be facing the page because the magnetic field here is represented using cross sign. Then as you can see, the velocity here has already aligned with our 4 fingers, which means our right hand palm is in correct position. And since the magnetic force is pointing upwards, then the charge will also have the tendency to move upwards.
Now let's take a look at this negative charge. As we can see, the magnetic field is pointing into the page and the velocity is pointing this way. So our right hand would be positioned like this. Since this is a negative charge, the direction of the magnetic force would be opposite the direction determined by the right hand palm rule. So the force would be pointing downwards.
The magnitude of the force can be determined using the formula F equals to QVD sine theta, where theta is the angle between V and V.
This is the view on how the charge would move in the magnetic field. So we can see this is just an uniform circular motion. The only force acting on the charge is the magnetic force. We can see that this magnetic force is always pointing towards the center of the circular path. Thus, the magnetic force for this is the centripetal force for this uniform circular motion. Therefore, we can equate the equation for centripetal force and magnetic force. We can see that there's V on both sides, we can cancel them, so we just left with V. So the equation is R is equal to mv over qb.
Next, we will learn about how to determine the magnetic force experienced by a current carrying conductor in a uniform magnetic field. So, first of all, we are going to determine the charge moving direction. In a straight current carrying conductor, the charge would move following the current direction. In this case, it will be moving to the right. Now, we can take our right hand and apply the palm rule to find the magnetic force experienced by the charge. In this case, it will be pointing upwards. Lastly, we can determine the magnetic force acting on the current carrying conductor by summing up the magnetic forces experienced by the charges moving inside the current carrying conductor.
Therefore, we can find the magnitude force acting on the current carrying conductor by using this equation, where sine theta is the angle between the direction of current and magnetic field.